let's solve this problem, right triangles, from the biweekly contest 129. So this problem is a bit challenging and this problem will test your mathematical skills. Now you can see here the acceptance rate is low, like it is only 40%. So it's like a challenging problem. You can learn so many concepts from this problem. Now we will see everything. We will see the mathematical proof and we will see the coding part. And first thing first, we should understand the question clearly. Now let's understand the question. You are given a 2D Boolean matrix grid. We need to return an integer, that is number of right triangles that can be made with the 3 elements of a grid such that all of them has a value 1. He's saying that we can form a right triangle so that my 3 elements should be 1. Now let's see. A collection of 3 elements of a grid is a right triangle if one of its element is in the same row with another element and in the same column with the third element. The 3 elements do not have to be next to each other. And he is saying that at least my 2 elements should be in a same row. Now if it is in a same row and if it is in the same column, then only I can form a right angle triangle. This is right triangle. So you can consider as a right angle as well, because you can see this is my 90 degrees. So at every point, at any given point, you should have the left one and right one, or the top one, or left one or the bottom one. If you have like this, you can form the triangle. You can form this triangle. Now let's see the question. Now I think you have got what exactly the question states. Now let's see the example, and this is the most important thing. The 3 elements do not have to be next to each other. That means I can have one point here and it can be my empty point, and I can have point here. So this is also a valid string. This is empty and I can have element here. So by this way you can form the right triangle. Now you can see here how many you can form. So this thing you can form, and you can form like this. So total I can form 2. Now if you see here in this, you can see these are in the same row, but I don't have any elements in the column, so you can't form. So only 0, right? Now let's see this example. Now you have 1 here and you can form like this. This is my one triangle, and if you observe carefully, this is my second triangle, right? So this is my second triangle. So how can you form this? Now let's see the small tricky part. Consider this as my midpoint. Consider this as my middle point. Consider this as my middle point. Now how many directions you can go? You can go top, left, right and bottom. Consider I am going to the top and it's indicated as A, B, C, D. So in this way you can form the triangles. Now let's see the small example. Consider we have, now this is my center point. This is my center point. You have A, B, C and D. Now first thing what I will do, if I have one point here and I have 3 points in this direction, so total number of triangles is 1 into 3, right? 1 into 3, it's simple. Here if I have 2 and if you have 3 here, then it will be 2 into 3. Here I have 1, so it will be 1 into 3. Simple maths. Now 1, this is 2, only 2 points are there, 1 into 2, okay. Now this is my 2 into 3, and this is my 2 into 2, so only 2 points are there. Now if you take one common in this, so you can form 1 into 3 plus 2. If you take 2 common in this, you can form 3 plus 2. Now my 3 plus 2 and 3 plus 2 are common. So if you take that common, then it will be 3 plus 2 into 1 plus 2, right? 3 plus 2 into 1 plus 2. What is 3 plus 2? Now you can see these are all my 3 elements. These are all my 3 elements and these are my 2 elements excluding this one. Same applies here. This is my 1 element and this is my 2 elements excluding this. That means at every point if you are finding 1, at every point if you are finding 1 here, you can do column sum and you can do the row sum and you can multiply it, right? You can multiply it, simple, because we have seen here, right, why exactly we are doing what we are doing. We are just 3 plus 2, which is 3 plus 2, and this is 1 plus 2. We are doing that. Now let's derive the formula. Now we have this as A, count A, B, C, D, A into B plus A into D plus B into C, C into D. Now if you take common A in this, A into B plus D, C, B plus D. Now these two are common, then B plus D, A plus C. That means A plus C, B plus D. So at every point, at every given point, suppose if you have a matrix, and at every point, what you can do, I can calculate the row sum, and I will try to calculate the column sum, and I will just multiply it. And one crux of the problem is, now you can see here in this, if you calculate the total sum of this row, it will be 6, but you need to exclude one point, because that will be my center point, you should exclude it. You can see here in this, only excluding this you should have the other point, that only will be multiplied. Now in the same with the column as well, you have here 4 points, but you need to exclude one point. Here you will be having 5 points in the column, in the row, and in the column you are going to have 3 points. So it will be row minus 1 into column minus 1. So what I will do, it's simple, right? Now I think you understood it, what exactly we are going to do. So try to code by yourself. So mathematical equation, I think you have got it. Try to code by yourself. Now suppose we will iterate at every row, I will maintain 2 rows, row, and I will maintain one vector called column, row and column. In the row I will push the count of each rows, and in the column vector I will push the count of all columns. And at every point, suppose if you are at this point, I will calculate the column sum, and I will calculate the row sum except this element, and I will multiply it. And if you are getting 1 here, same you will do row sum, column sum, multiply and minus it. So I think you have got it. So let's see the high level of the coding part. Try to code by yourself. So if you are unable to code, then you can see the coding part. Now it's simple. We have row and we have column sum, row sum and column sum. We will iterate to the each column, first each row, and we will push into the row vector. In this, we will iterate to the each column and we will push into the column vector. Finally, this is my long K, row minus 1 and into column J minus 1. We have seen here, right? This will be my row I and this will be my J. So row minus 1 we need to do. You can see here row minus 1 and column minus 1. We will do that. And if it is greater than 0, then I will add into the answer, and finally we are going to return it. So if you are using C++, you can see this is my long. So you should use long, otherwise you will get memory limit. So I think you have got it. So if you learned something new from this video, please do like, and if you are new to the channel, please consider to subscribe. Now let's see the time complexity. If you see here, what we are doing here, this is order of n into n, right? Same thing, n into n into n. So 3 into n into n, but overall you can say that it will be n into n, and we are not using any extra space. Sorry, we are using extra space called row and column. So it will be like order of n. So I think you have understood it, and I have created a WhatsApp community, and there we have couple of good students where they will discuss lot of problems from the LeetCode. You can join that, and you can connect with me on LinkedIn. I have given all this in the description. Thank you. I will see you in the next video.